Welcome and thank you for tuning in. My name is Christian Kutscheit and I'm responsible for the sales development of the process control system SIMATIC PCS7 and the simulation platform SIMIT. My colleague Jana Vukas works for the system and project support and is our technical expert for PCS7 and SIMIT. Together, we would like to give you an impression how you can create sustainable value by using SIMIT as a key lever for digitalization in automation projects over the whole plant and machine lifecycle, especially in tough times like this, where nearly everyone is forced to work from home. Let's have a closer look to the key questions of our customers within the lifecycle. For the engineering and commissioning phase, our customers ask for higher engineering quality to reduce risks and increase time to market. The important questions for the operations phase are with regard to a higher operational efficiency and well-trained plant operators.
Thank you for your introduction, Christian. You mentioned the plant life cycle. Can you tell us more about the challenges which your customers are facing in the commissioning phase and why it gets more and more difficult for people working in this phase?
Of course, there are several challenges during the commissioning phase that people have to deal with. Just let me point out only a few. First, I'd like to mention, in most cases, real hardware is necessary for testing. So that means along with rising costs, there are long delivery and installation times. Secondly, some delays, such as delivery delays or missing infrastructures, or even other circumstances like unclear or changing requirements, are not foreseeable and makes it hard to guarantee previously agreed deadlines and milestones. That means at the end of the commissioning phase, tests can only be executed under extreme time pressure and with limited error analysis. It is often the case that there is a loss of quality in the project. Some errors may sneak through. Therefore, the testing phase is expensive and elaborate, and you don't know if the automation project data are still consistent.
Well, the points you mentioned let me overthink the potential of digitalization. We are often talking about the digital twin and especially the benefits which integrated engineering and simulation offer. So can you tell us why it becomes crucial to create a digital twin of the real plant or machine and what advantages do you see from a virtual commissioning?
Gladly. Nowadays, getting products onto the market faster or doing modernizations with consistently high quality requires an optimized engineering workflow in the area of automation, while also needing the shortest possible construction and commissioning times for new or changed production lines. Simulation can take place in parallel with the engineering process. Early identification of errors and more extensive tests performed on the automation solutions improve the quality of engineering. This avoids costly reworking and later conflicts. SIMIT enables the creation of simulation models and its emulation so that automation solutions can be comprehensively tested. In other words, plant can execute a virtual commissioning. We say SIMIT simulates what SIMATIC automates. Virtual commissioning allows the simulation and testing of the automation functions even before the real plant exists. Virtual commissioning can be conducted with the original automation software at any time and any place by only having a PC station available. Especially in times of home office, SIMIT is suitable for shortening both the commissioning time and start of a production because the software can be used perfectly from any location and access to real hardware isn't necessary anymore. Jana, could you tell us what technical aspects can be proven by SIMIT during virtual commissioning?
As you already know, SIMIT consists of 3 different levels: the signal, device, and the process level. Virtual commissioning affects all these levels. At the signal level, signal and loop checks can be conducted easily by forcing signal values. Decoupling can be done with the real hardware of the automation systems, also called hardware in the loop, and with the integrated virtual controller or the SIMATIC S7 PLC SIM Advanced, and therefore without any real hardware besides the PC station. This is also called software in the loop. In the hardware-in-the-loop configuration, the automation program is loaded via the SIMIT unit in the real automation system. The SIMIT unit is mainly responsible for emulating the bus and device level, which are not available in real. With the software-in-the-loop configuration, nearly everything will be emulated from the controller up to the process level. Imagine that you should have all the devices of your plant available for testing. What a procurement and logistics effort it would be. unthinkable in times of digitalization. But let me continue with the device level. At the device level, the functionality of modules, drive, actuators, and sensors, like for example interlocks, signal status, and answering times, can be proven in detail according to the complexity of the simulation model. At the process level, the planned behavior with all corresponding process values will be recognized and set in the context of the device level, so the connection between the device and the process level can be proven as well. Therefore, integrated engineering plays an important role in the context of creating a simulation model.
There is that term again, integrated engineering. Can you help everyone and explain more about what that really means?
Sure. Integrated engineering means mainly working with consistent and object-oriented data in all our tools to build up holistic digital twins. Typically, customers in the process industry utilize a process control system like SIMIT PCS7. For plant or automation engineering, our customers are mainly working with special planning tools. Within our company, we have several planning tools available, like COMOS for plant and design engineering, or SIMIT PCS7 Plant Automation Accelerator, short also known as PAA, for automation planning to support our customer as much as we can by the planning of their plant. With those tools, we gain an integration of automation data and enable a consistent and bidirectional data exchange. Of course, this integration of automation engineering data works also with SIMIT. The interface between SIMIT PCS7 and SIMIT enables a hardware configuration exchange. The transfer of this data into SIMIT, primarily the symbol table in the form of inputs and outputs with associated address range, is required for the creation of emulated controllers. From the PAA, already engineered object-oriented automation data can be reused by SIMIT. By the import of the automation data, the device level, which can be based on templates, will be automatically generated. The functionalities of the generated devices and their signals can be tested using the behavior models which were automatically created previously. As an alternative to the extraction of the automation data from PAA, it can also be transferred directly from PCS7 to SIMIT. After bringing all necessary data into SIMIT to finish the simulation model, the virtual commissioning phase can be started. When the virtual commissioning of the plant was done successfully, the automation data can be used for the real plant and the real commissioning can be realized within short time. By using our integrated engineering portfolio, our customers have shorter project durations due to consistent data synchronization between engineering and automation, and the possibility of early testing and validation of individual automation functions, system components, and even entire systems. All in all, they have a better economy through intelligent fusion of the digital and real worlds.
Thank you, Jana. Does that mean if somebody wants to use SIMIT, do they need PCS7 or one of those other tools?
No. SIMIT is highly flexible and has on the software side a lot of coupling possibilities to other third-party DCS systems, TIA Portal, and many more.
Now the term is much clearer to me. Thank you. Well, if we look back to the life cycle of a plant, in addition to engineering and commissioning, we also have the operation of the plant. With SIMIT, it is also possible to set up operator training systems. And that's the second main purpose using SIMIT as an answer on these questions. As an example, like many airplane pilots we know, they have frequent trainings in a flight simulator. So this same concept can be transferred and adapted to the production plants. After building up the complete digital twin of your plant, operators can be trained on various plant scenarios via simulation, even on the most dangerous ones. So that means due to trained operators, the plant availability will be increased substantially because outages and non-productive situations, for example plant downtimes or changes of production, are avoided. The fact that the operators can respond faster and correctly to unusual or critical plant situations also makes the plant much safer. Potential breakdowns will not have any consequences, which helps to avoid costly damages to the plant while ensuring employee safety. Jana, could you please show us in detail how an operator training can look like?
Indeed, I can. As mentioned before, operator training systems are highly orientated to train the operator on a basis of the real automation system most efficiently. If there is an already existing digital twin from virtual commissioning phase, of course, this one can be also used as a base to build up an operator training system easily. Let's have a quick look at the capabilities of SIMIT in this area. Two helpful features of SIMIT regarding operator training systems are the possibility of doing snapshots and the virtual time management. The snapshot functionality allows users to save specific simulation states, including the automation state. In the training as well as during simulation supported engineering, these snapshots can be called up and run as often as required until the operator or engineer knows how to handle this kind of plant situation. This saves extensive time not having to manually reset up the entire training situation. Maybe certain valves need to be opened, or motors turned on, or you have to wait for pressures. With a snapshot, you are immediately back at the scenario you want to be at. In addition to that, there are sometimes slow processes which are very time-consuming, and they can be accelerated by using the virtual time management in SIMIT. There's no need for an operator to wait 20 minutes in a virtual environment, and on the flip side, fast process can also be slowed down. This may help the operator better understand what is happening with the process and allows them to practice operator actions in less hectic environments, and after some training, they will be ready for the real thing.
Wow, that's impressive. We have seen a lot of details of operator training systems. In summary, one can say, having a digital twin of your plant guarantees increased efficiency as a result of higher productivity because of improved automation functions and a greater operational efficiency due to operator trainings in advance over the entire plant or machine lifecycle. Your benefits in engineering, commissioning, and operation. Seamless transfer of engineering data. Simulation and testing of the automation functions. Efficient and smooth system startup of the real plant. Avoidance of error and costly reworking, and increased safety.
We are your partner in digitalization, simulation, and integrated engineering. Contact us today to realize the digital twin of your specific plant to increase productivity, cost savings, and efficiency of your plant.
Thank you for watching our video. Stay tuned and bye-bye.
Siemens, ingenuity for life.